Great. Yeah, good evening. Welcome to this talk. My name is Dockter. I'm the founder of Gradle and the CEO of Gradleware. And today I talk about best practices, patterns, and processes for doing continuous delivery with larger stacks. So this is not a tool-focused talk. It's not about tooling and how to apply certain tools. I also love to talk about that. So if you're interested in this, I'm going to present the new Gradle-based Android build system tomorrow at 9:30. Okay, so the focus of this talk is software that is made up out of components and is released in one chunk. If you have a component-based software stack and with independently releasable components, all what I'm telling here is equally applicable. You just have some additional complexity on top of that regarding continuous delivery, where we don't have the time today to dive into that. So we will talk about different ways to structure the code base, the challenges and the different ways of building such a code base, and how you should model the promotion aspect. So when a developer commits a change, when and how should it be exposed to his team, when should it be exposed to other teams and to QA, and so on. But I would like to start this talk with a question and a discussion. Are there kind of simple best practices for continuous delivery? Right? So for example, let's take the statement, if you build such a component-based app, right? When you build this, you want to have maximum integration pressure between the components. Who think this is kind of generic principle when doing continuous delivery for such a software stack? No one. Wow. So, I mean, this is the way Gradle does it, maximum integration pressure, right? This is the way LinkedIn does it, this is the way Google does it, right? You, as soon as you commit a change, it's completely automatically integrated with all the other components, right? But there are situations where things might be a little bit different. So, for example, what if quite a few of your components don't have any tests? Do you still want to immediately integrate with changes of those components? What if it takes 10 hours to build your software, right? Which means once something is broken, it takes a lot of time, it takes a long time to fix it. What if you have a distributed team, one in Europe, one in Australia, with a time zone difference of 12 hours? What if two component teams hate each other and there's a lot of politics involved? What if there is a team producing only crappy software, but their project lead is the son-in-law of the CEO? I don't want to have a strong integration pressure with that team, that's for sure, right? So, so the point is that continuous delivery and the best way of doing continuous delivery, it heavily depends on the reality of your organization. Whether you hate that reality or not, that doesn't help you. You have to embrace it to do proper continuous delivery for your organization. And the arrow is also going in the other direction, fortunately. So continuous delivery can help significantly. I even think it's a critical enabler for improving your code quality, for improving the way your developers can cooperate, right? So, for example, one of our clients, years ago, they were in the following situation. A couple of hundred developers. The build time was 6 hours, an old legacy application. On top of that 6 hours, it took them almost a day to deploy a new version of their distribution to WebSphere, so that QA could test it. And then they decided, hey, let's do Scrum. So, and you can imagine what happened. the whole idea of having a continuous feature flow and stuff like that, it didn't work. Changes piled up and piled up and piled up, but stories were hardly ever done because of the long feedback cycles, and 2 months before release mode, they completely fall back into the waterfall model. QA was working 24 hours a day, and it was just impossible with their continuous delivery tooling and process to do Scrum. They introduced another build system I'm involved with, and their average build time went down to 20 minutes. And that was a game changer for them, how they could organize themselves to produce their software. And that is a very important aspect of the continuous delivery process. Sometimes what you also see is that continuous delivery and continuous integration is practiced as a ritual, right? So you have to do it nowadays, but you don't take it very serious, then you might as well not do it. But you can hardly afford not to do it nowadays. I mean, some organizations are competitive-wise in a comfortable situation that they can afford to produce a lot of waste. But if you look at the amount of waste that is produced in our industry because of insufficient continuous delivery processes and tooling, it's sometimes breathtaking. So, for example, I know of one company, 70 developers. Every day they came to work. They had a large software stack, a 600 submodule build, old legacy application, everything in one source tree. Every day they came to work. Each and every developer started the day with SVN update, took 20 minutes. The next thing was everything was imported into the Eclipse workspace. Eclipse refresh, 40 minutes. Every single day. Some developers like that. Another cup of coffee, and they tell their friends, hey, I have a really good job. Do you want to join? Other developers hate it. You know, you can't get anything done. You feel very unproductive. So in such scenarios, continuous delivery really affects who is joining your company and who is leaving. On top of their 1 hour waiting time, they had a build that was taking multiple hours. They had a virus scanner that was checking the build output directory. They wasted multiple hours a day for nothing, right? And they could afford it because of the business situation they were in, but it's rare, right? On the other hand, if you look at a company like LinkedIn, who, for a massive software stack, changed their release cycle from once a month, which was already above average, to multiple times a day, imagine you have to compete with them, and you are slower than they are. You are in trouble. So I think even now, hardly any company can afford not to invest into that, and in the future it will be even less, right? So, what I want to present now is a couple of patterns I usually come across when I look at how organizations build larger software stacks, and I want to discuss their advantages and disadvantages. So, a typical pattern I see, I call it binary integration. So what is this pattern about? Each component has their own version control repository. Each component has its own build. And of course, the components have dependencies between each other, right? So if a component has a dependency on another component, so the downstream dependency has a component on an upstream dependency, this dependency is retrieved from binary repository. So if people who know about Maven Snapshot know how that works. It's one way to implement that. And one question I have for you when you use that pattern, and who of you is using a similar pattern like that? So how do you learn about? How do you learn about whether you've broken an downstream dependency? So I learn now if an upstream dependency has broken me, but how do you learn that you've broken a downstream dependency? Can you ask your local build for doing this, for giving you that information? I'm sure many of you know the answer. The way this is typically done nowadays is via CI job triggers. So if I have jobs that represent my component, and if a downstream component depends on an upstream component, you can configure a job trigger, which means if the upstream component changes and the build is successful, CI automatically triggers a rebuild of the downstream component to learn if that change has broken anything. So it's modeled on CI usually. It's not a very rich model. So let's look a little bit deeper into the pros and cons of that pattern. So what is good when you look at that pattern? Well, you're doing continuous integration, full continuous integration via the continuous integration server. This is good, right? The local build does some continuous integration. It checks whether upstream has broken downstream. And a major reason why many people introduce that pattern, the build is fast, even with the legacy build tools many of you are using. So what are the problems of that pattern? Well, you not just have a single build. If you have 50 components, you now have 50 CI jobs to manage per component, and usually you have more than one job per component. So you easily have hundreds of jobs on CI to manage, and as many, and 50 builds. But the serious problem and the serious disadvantage, potential disadvantage of that pattern is there is no local way to check whether you've broken downstream before you commit to version control. So that might introduce possibly many breakages. I can tell you about one project, and I will talk more about that later. They, for a large code base, 500 developers working on it, they introduced what I call naive continuous integration. They said, okay, let's use the binary snapshot pattern, and we're doing proper continuous integration. So what happened? Because developers couldn't figure out that they've broken downstream, they always had to commit. CI was broken all the time. It was just, QA had to wait for weeks before they could get another version they could test. And they had to do a little 1 or 2 day feature freeze to get to that state. So they completely lost their capability to ship software. So there was for them, this pattern definitely didn't work at all. For other smaller scale projects, it might be exactly what you want, right? So the feature flow is in danger, and you might have many breakages on CI. But there's another very important aspect, I would like to talk about. Many people, when they talk about continuous delivery, they only think about this production pipeline for producing your code. But another key aspect of a continuous delivery tooling is to make it easy for the developers to do experiments, right? So, and if I can't do this locally, if I always have to commit to get the feedback from CI, this is much harder. So for example, I did some local changes and now want to see whether they have affected the performance of some of the modules that depend on my module. Or another example, you had some intense debate within the team whether you should do a certain refactoring or not. Certain teams were opposed. Other teams liked it. At the end of the day, you won. The changes are made. But the other two teams, they're just waiting that stuff is not working. So what you want to make sure of, you want to have tooling that makes it very easy for you when you do a local build to figure out before you commit whether you've broken the components of those teams or not, just for political reasons, right? Another good example is, you know the change you're doing might be a breaking change, right? And there might be a simple solution to deal with that might be, hey, build system, tell me which components have I broken. And then you get a list. And then you can pick up the phone and talk with those teams and say, hey, I would like to commit that change. Will you be around tomorrow? And then I commit it. Everything will be broken for a while, but you make sure that the other teams have the bandwidth to fix it and to adapt to it, right? Another disadvantage, whether it's relevant or not, depends on your situation. You're not integrating against the latest from source. You're integrating against the latest binary. There is a latency. It might be a couple of seconds. It might be a couple of hours. So you have less integration, basically. Whether it's relevant or not depends on your situation. Okay, so This pattern sometimes works reasonably well, sometimes not at all. And then you could also call it the desperation pattern, branching. There are multiple ways to do it. One way is to do it also on a binary level. So similar setup as with the binary integration pattern, except that for the upstream dependency, you no longer depend upon the latest, but you depend on an old version of that component, right? So what is good with that pattern? Well, good feature flow, or the illusion of good feature flow, right? I mean, you make good progress. Nobody is breaking you any longer, so QA can test your features and stuff like that. So you can consider this as an advantage if you like. The local build is fast, similar as with the binary integration pattern. What is problematic? Similar to the binary integration pattern, quite a few jobs to manage. But that's the problem. You might do continuous builds on CI, but you're not doing continuous integration. So you're just waiting for the nightmare to happen, right? We all know that. Late integration is just the most risky thing you can do. You risk to miss your release date. You risk that you have produced a lot of waste because you figure out late that components don't work well with each other. You might have to redo a lot of work. So it's a disastrous pattern, basically. And but some people just don't discover a better way of doing things. So I still see this around a lot. An alternative is that people do it on a source level, right? They have one big source tree, and then they have long-living feature branches. That's another way to achieve something similar. And then there is my friend, the single build pattern. It's often, for some reason, considered kind of old school. I don't know exactly why, but there are a lot of benefits with that pattern. So how does it look like? All your code lives in a single version control repository, and there's a single build to build it, right? So what is good with that pattern? It's simple. One build pipeline. Very nice. Continuous integration is built in, right? So you don't need to set up any job dependencies, and also on your local build, you have full continuous integration. If you build, you always check, do I work with upstream, have I broken downstream? Before you commit. It's often invaluable. So exploratory learning is very easy. What is problematic with that pattern? Well, I would say fundamentally, you can solve most of the problems I now mentioned, but many people run into these problems and they're struggling with how to solve that. IDE mapping is a problem. For example, LinkedIn, their Cradle user, they have a single 3,600 submodule build. If they would naively import that into Eclipse, how long will the refresh take? I would assume possibly even a full day, right? Anyhow, way too long. So if you just say, hey, do some automated mapping, that doesn't work because the IDEs don't scale with that. So, but you can do smart stuff, right? And that's what they're doing. You can have dynamic IDE configuration depending, for example, you can check, hey, what team is that developer in? This team only wants a subset of the components to be explicit Eclipse project dependencies. The other components, they are in Eclipse modeled as binary dependencies and stuff like that. So you can do a lot of cool stuff to solve that problem. Version control system performance. We have quite a few clients who are using ClearCase. Don't know who ever had the pleasure to use that tool. Performance is a disaster, right? So for them, this pattern would be a real problem together with ClearCase. But even other version control systems are not performing necessarily well enough, but modern version control systems perform much better, and they push the limits of this pattern quite a bit. A major reason why many people moved away from this pattern was build performance, right? Because you had build tools that were always building everything, and if you look at LinkedIn, if you always have to do a full build for a 3,600 submodule build, that doesn't fly, right? So the local build should be faster than 10 minutes in average. So you need tooling that can deal with that, and despite the scalability challenge, still provide very fast feedback. But it's possible. Release management, yeah, you have to synchronize with all the teams when to start a release branch and stuff like that. If you have separate repositories, that's a little bit easier. The interesting and impressive thing with that pattern, there's one company we all know who uses that, and that is Google. For thousands of the developers, they have a single source tree. And what they do additionally, with all the components they have in that source tree, they release them independently, without any release branches. So if they fix something, they always release from head, right? It's really impressive. They can do that because they have an excellent test coverage, they have an excellent build farm, they have very fast feedback, so they can do a lot of local checks before they commit, etc., etc. So this pattern scales astonishingly well. But again, it has to fit to your organization. There's only one company like Google in the world, and with the developers they have, they can do that. Most organizations, let's put it like that, are more heterogeneous when it comes to skill set, when it comes to code quality. So, breakages might still happen too often with that pattern if your build time is very long. If your build takes 5 hours, right, then you probably anyhow don't want to use it, but then during that 5 hours, other people have committed stuff to version control, and then the CI build might still be breaking too often. Okay, so I want to give you an example of a challenging project, and then I would like to discuss what pattern would work for them. So here are some of the facts. 500 developers, Java and C++ code base, 15 years old legacy code base, 50 components, 20 teams, distributed Northern America and India, 1 year. Plus the way they ship their C++ services. Build time, 14 to 24 hours. So they always manage to compile, which is in C++ land a little bit more challenging, especially if you don't have a local build. How do they do that? Because they don't have any local checks. People just commit, basically. They do it the following way. They start a nightly build in the evening, Northern American time, and then if it breaks, let's say 2 a.m. in the morning, then India is checking whether they can fix that problem or not. If not, they call the build team in Northern America, who is asleep, not much longer, but then they get up, try to fix it. If they can't fix it, they call a developer. They have been extremely burned by the fact that they couldn't produce a releasable ear for months. So they have a heroic discipline to at least get the thing to compile and to package once a day. It's an amazing effort. I've been there. I've seen their eyes after such a long night. That happens multiple times a month. So after they're able to produce the ear, they don't have many unit tests. As often with such legacy applications, they have 4 hours of UI testing with frequent problems. And then they have to decide, is it worth to deploy it to QA or not? The local build is basically non-existent. So what do you do in such a situation when you want to produce a new version, release a new version for your clients? They ship software for a living. Because things are so unstable, they have a very early freeze. They have a 6-month freeze period for doing the release. Right? That's the only way they manage to survive. But there is another really nasty and vicious problem here. This is a 15-year-old legacy code base. You can imagine how much technical depth you accumulate over that time. And now there's a lot of friction between the build engineering team and development. Build engineering, their preferred way of development is do nothing. So there's a lot of friction to push the developers to be very conservative with the changes. So instead of paying back technical debt, they accumulate more and more of it, and it's just a question of time when this thin ice on which they are walking completely collapses. Right. So what to do? I mean, one thing is for sure, there's no free lunch for that problem. It's a serious problem with the current tooling we have. It's a really serious problem to solve. So this is what we came up with them. It's a new pattern, call it Watergates. How does it, and I will explain why later on, not because it has something to do, it's about corrupting, bribing your clients that they don't complain, no. So you have separate component builds and separate version control repositories for your components. But let's look at a picture. When you depend on another component, when you have an upstream dependency, you don't go against the latest, but you don't go against some fixed old version. You go against latest promoted. I will explain later in detail what that means, right? Additionally, there is a place you can query where a particular build of a component can ask, hey, what are the components that depend on my component? So that you can have downstream awareness. So that is the setup. Now, the pre-commit build. It's key to make it much stronger. The pre-commit build uses promoted upstream dependencies. When I have a dependency, I get a promoted one. It is downstream aware, right? So, and now, of course, you might run into issues. The pre-commit build shouldn't take longer than 10 minutes, right? So you might figure out running all the integration tests against all the downstream components takes way too long. If I'm a developer in the core module and all the other modules depend on my module, it's just out of reach, right, for them to do that. So, but then you can be smarter. You can say, okay, let's test only against a subset of the downstream modules, and then let's not execute all the tests. Let's find a pattern that the upstream team can give some hints that certain tests are give a strong feedback whether the collaboration between the components still works. So you don't execute all the integration tests, but only a subset that are particularly focused on checking the interaction of those two components. Right? So you can be, any integration test you execute there for downstream checking is so much better than none. Right? And then you have to think about how can you get more and more quality into those 10 minutes. But even if you start with one integration test, whether you've broken downstream, it's big progress, right? It needs to be fast, pre-commit build, no question. So then every component team has their own CI component build. The CI component build also uses promoted upstream for its dependencies. It's downstream aware. It does some deeper testing. And now comes the key part of that. If the CI component build is successful and it's downstream aware, then the component produced by that CI build is promoted and is now exposed to all the other components. Right? So you have now, we try to find a balance here between not doing too much integration pressure because it doesn't work for them versus not doing any continuous integration at all, right? This is the fine line we're trying to find here. And then there is the full build, which builds all the promoted components. It's now much more stable, right? And you have a much better feature flow. This doesn't work without a strong focus on performance. So you need parallel builds, you need at least distributed integration tests, and you need really smart tooling that do a lot of build avoidance if stuff doesn't need to be done. For example, you can figure out, hold on, I just did an update from version control, right? And there are some changes, but instead of building those changes myself again, I might ask the cache to say, hey, do you have a binary for that commit ID? Then I don't need to do it myself and stuff like that. There's a lot of smartness you can do. So making it easy to throw resources at the problem and high-level build avoidance is key for bringing performance to another dimension here. Of course, there are challenges. There's no free lunch. if there are no tests, all the promotion looks very good on when you present it, but the message, hey, this is promoted, is not a strong message because there haven't been many automated tests to check that, right? So you need tests, otherwise you will be still struggling. A key problem I often see in organizations like those, the test infrastructure is not automated. So there is a manually maintained test database with manually maintained test data, which makes, on the one hand, integration testing very fragile, and of course it makes it very hard to do it in a distributed way and spin up as many machines as you want, right? And you have to invest quite a bit of time into making this work. But what choice do they have, right? There might be potential resistance. So, as I mentioned before, infrastructure that sucks or that makes it, that is so problematic and insufficient, makes it very easy to hide behind that, right? And it makes it much harder to make someone accountable for his or her work, right? Another problem is there is less CI pressure. So I can now take it easy. The crappy team with the son-in-law of the CEO, he can now take it easy because the latest promoted version is 2 years old, right? It's only crap, everything fails, but no one is complaining. So this is now a situation where continuous delivery tooling and the build team has to say, we can't do anything about that, right? But what we can do, we can provide really good reporting to figure out, hey, this is the delta between latest promoted and latest from source, and you can automatically generate that, and then it's a question whether the organization is capable to react on that. So what you can do regarding less CI pressure, provide data so that some red lights go on if the delta is too long, right? Another interesting thing here, and that's why I call the pattern water gates. Some teams might decide, hey, we don't want to integrate via latest promoted, right? We sit in the same room, we work together very well, we are very ambitious, and we are tightly coupled in what we're doing. We want to integrate against latest from source. So we always want to get promoted together, right? If one breaks the other, neither can be promoted. Right? They want to have stronger integration pressure. So you want to have an infrastructure where it's very easy to model the quality gates on the local build, on the CI build, that you can say, between those components, I have latest promoted, between the other components, I have latest from source. Another challenge, we don't have time to talk about that today, is library management, right? Dependency management. So, and I already mentioned that, reporting is key for continuous delivery infrastructure. Automation can't solve it all. There are many problems where continuous delivery can only model around them, but then provide hints that something is organizational-wise or infrastructure-wise not working properly. And at the end of the day, it's a statistical game to find that balance between integration pressure and reasonable feature flow. So you have to continuously check the statistics, do root cause analysis to decide how you want to change the quality gates, right? Do you want to have a little bit less integration, but therefore better feature flow, or you might find interesting evidence to say, hey, we really have to invest into that components, into the testing and stuff like that. And that is a moving target, right? Components that behave well might not behave well in 3 months, maybe because the project lead has left the company and whatnot, right? So the situation, in my opinion, we are as an industry is that any serious continuous delivery effort is still a pioneering effort, right? So I know only of a very few companies that on a large scales have a very advanced continuous delivery process. Google, definitely, LinkedIn, but they're not many, right? So, and they reached that point only because they had a lot of skills, a lot of brain power, but also a lot of resources. Those are companies that are driven by engineers, right? And so they had the backing from management to invest into that. And basically, what we see as the mission for Gradle, just as a side note, is we want to dramatically lower this barrier, so that you don't have to be one of those few companies, but that it will be that you can get there with reasonable effort. It's never a free lunch. It's always a big investment you have to do. Also, investment into changing the culture, but at the moment the bar is very high, right? And so the tooling needs to improve, and that is our mission. And the other thing that is where it's also a pioneering effort. All these talks, we had two pattern talks about continuous delivery right now here at Devox. So conceptually, the domain is also not that well understood at the moment. So it's not just a tooling problem; it's also a patterns problem. We need to think more about it. We need to think deeper about it. So things will definitely improve, but as I said, we're still at the pioneering phase, in my opinion, right? And our company helps with that. Yeah. So, do you have any questions? Yes, please.
Actually, two. The first is that you're still in the pioneering stage, and you showed us the fact before how long the build took and everything. Do you have any numbers for us how the build changed after you put the Watergate pattern?
Yes. So, so we have a couple of numbers from various projects. So it is what we often achieved is that the build time went down from hours to something like half an hour, right? So the problem with we are still working with that client, so the C++ stuff is still done the old way and things like that. So this is not a good example yet. The key is now to make the next step. So so with the tooling we provide, you can already make a lot of progress with parallel builds, with incremental builds, with build avoidance. But the key, I think, is to go distributed, right? And that's where we for building the whole code base, where we're not quite there yet, right? So what we do sometimes, we do something handcrafted for a particular client, but it's not available in a generic form yet, right? So that is for me the next step, where you get those build times that were reduced to 30 minutes to 20 minutes down to seconds eventually. That must be the goal, and that will be then a complete game changer. I have a couple of books, so 4. Do I have them with me? 1 second. Have I forgotten them? No, I haven't. So, if you want a book, please ask your questions. It's books on Gradle. So I should have told you that. Yeah, right. Oh, now the hand's going up. Great. So yes, please. It's a good question. We usually do incremental, right? Okay. The question was on the pipeline. Do we do on CI? Do we do incremental build or full builds? We try to do incremental builds. Maybe the final release build for the clients we do, or we have one nightly build where we say let's do a clean build. But we try to use as much incremental build as possible. Yes, please. The main difference between Gradle and Maven, there are many. I mean, that's another talk basically, because there are many areas. It's a complex domain: dependency management, performance, maintainability of the build, all the stuff I talked about. How you can map smartly a large multi-module build to your IDE, distributed testing. There are many aspects. Yes. Thank you. So there was a question over there.
Yeah, with the single source approach.
Yes.
You have a lot of components that have very different life cycles being released.
Yes.
Do you run into problems then with things like versions in the build number?
So the question was with the single source approach, when you have components with independent life cycle, right? How does it work? Well, there are two ways you can do that. You can say that you consider this, for many companies, that is then a reason to move away from single source and have repositories per component. But they often don't see the complexity. I've been with companies that are saying, oh, we want now to have an independent release lifecycle for all our services. Then they have 200 services that are built independently. How do you do continuous integration? Because you have no idea which server is deployed to the other service. Then you have a really complex matrix. You need to test one service against the latest of a service it depends on and against the version of the service that is deployed. So when you have 200, this becomes completely unmanageable, right? So this is a problem. Or you do it the Google way to say, who cares, right? We deploy from head. We have good tests. We have frequent releases. And somehow they manage to ship software, don't they? And then sometimes when I tell people, hey, Google is doing it like this, they look like, first they don't believe it, right? And then they say stuff like, well, it's just a search engine, right? And our domain is much more critical. Well, then look at the money they make and the money they have to model the transactions for and stuff like that. That argument doesn't fly very well. Yes, please.
Is it possible to build in parallel on multiple machines?
We do it for testing. It is not yet possible with our tooling or any other tooling I know, but that's a key thing we are working on.
It will be possible in next release?
Pardon? Will it be possible?
In next release of Gradle?
Oh, not in the next release, but sometimes next year. Yeah. Oh, sorry. Whether it's possible with Gradle to completely distribute your build, right? So that you have a single build and you distribute it on multiple machines, right? So what many people do at the moment, they use CI for that, right? In some form with multiple agents, but that's something we want to make really first-class citizen, but it's not there yet. Yes, please. It depends on the domain. So that is another thing I forgot to mention. So I think we can't do continuous deployment. It's great. That wouldn't make any sense, right? We need to have a manual beta phase and stuff like that as a distribution that is providing critical infrastructure that is downloaded and locally installed. For us, continuous deployment, that doesn't make sense, right? No company wants to use every day the latest from Gradle or whatnot. They want to have it's too risky for them, right? And for other domains, it makes a lot of sense, right? So it depends, do you want to have, do you need some manual testing phase, or other domains like medical devices, right? When you have domains that have a lot of regulations. So we have one company that is doing medical devices, and they get auditings regularly. So when they can't, for example, prove that they are still able to rebuild the software they have released 1 year ago, they need to recall all the devices they have sold already to the hospitals, right? So they need to have special auditing phases and stuff like that. So in general, if you can, go with continuous deployment, absolutely. But it doesn't work for each and every domain. Is that an answer to the question? Yes, please.
The single build pattern, does it also mean so that all projects are in the same repository and all projects are in the same trunk?
Yes, that's what it means, yes.
So also, when you go to production, you go with maybe one feature that's finished and all other features are half done?
Possibly. So what is the problem? I mean, if you have a good if you avoid breaking changes, if you do kind of a deprecate remove style of development. So let's say you want to replace an old feature with a completely new way of doing things, right? If it's half finished, it's half finished. Then it gets finished in the next release, and stuff is still working, right? I mean, it depends all now then on your development productivity, but basically, I don't see a fundamental problem with that.
But then you cannot commit often and continuous delivery.
Pardon?
Then you cannot commit often and do continuous delivery.
Why? Then you cannot commit often and do continuous delivery. Why can't I do that?
Because if you're in a process of development, you have some incompatible changes, which will break the build, so you cannot.
Yes, so that's what I said. You should avoid incompatible changes, rather do deprecate and remove style. So you introduce something new, which is not replacing something old, right? And then you check it out, then you deprecate the old way of doing things so that people get a warning for 2 months, and then you kill it, right? Okay, yeah, thanks a lot for your attention. Really enjoyed it.